All right, guys, so where we're picking up today is where we left off yesterday. So we got to at least to this here, maximum and minimum values. Talking about the maximum and minimum values of a function. Now we talked about when the graph opens up, it will have a minimum value. It will have a smallest value. And the minimum value is going to be at the vertex, the y value of the vertex more specifically. The domain for either one is going to be all real numbers. The range when the graph opens up is going to be y is greater than or equal to whatever the value of y is at the vertex. And then we'll talk about domain or increasing and decreasing. We also talked about when a graph opens down, the vertex value, the y value of the vertex, is the maximum point, the largest point. The domain is all real numbers. The range is going to be y is less than or equal to whatever that y value is. And this is where we started. Now we looked at this here, and we have this function. Y is equal to 1/2 x squared minus 2x minus 1. Yes. Okay. Yes. All right, guys. So we're going to look at this here in the graphing calculator. So the first thing we're going to need to do is actually type the function in. We want to type it into the graphing calculator. So our function is 1/2 x squared minus 2x minus 1. So the first thing we need to do is first hit y equals, and then we can get the fraction. So we can say alpha y equals, enter. And we can do 1/2. Oh, not hit enter. Then we will have x squared minus 2x minus 1. Because we want to type it in, 1/2 x squared minus 2x minus 1. And once we get that typed in, we can go on and hit graph. Yeah, if you need a calculator, you can go on and grab one. Now, when we look at this here, we do see that it is opening up. It is opening up, so we will have a minimum value. We'll have a minimum value somewhere down here, because a point down here will be the smallest value, the smallest y value for this function. Now, if we want to find it, we can actually use the graphing calculator to find it, to calculate the minimum value for this function here. Now, before we start calculating the minimum value, has everybody been able to graph this function? Yes. Okay, let me see. So you did y equals, typed it in. Yep, that should fix it. So we can say y equals, well, we can type it in alpha, y equals, enter. So 1/2 x squared minus 2x minus 1. Y equals alpha y for the 1/2 x squared minus 2. Now, if we want to find the minimum value, we can go second trace. Second trace. We know we want to find the minimum value because, again, it opens up. We do have a lowest point. Now, normally we can scroll down to number 3 and hit enter, and it would give us the minimum value. Now, since the 3 is next to it, try just hitting the number 3. It's going to calculate minimum for us because we can use those numbers as shortcuts. Now, whenever we find minimum, maximum, or any of these here, the first thing it asks is left bound. So we need to pick a point to the left of the minimum value. Well, is the little blinking X already to the left of the point or left of the minimum? Yeah, so we can just go on and hit enter. Now it wants it to be to the right. So we have to click on the right, or click over to the right, until we get the X past the minimum value. And it really doesn't matter how far past we go, we just need to make sure that it's between the 2 points. Now once we have that X past the minimum value, we can hit enter, which will give us 2 arrows pointing towards each other saying that the minimum value is between these 2 lines. And then we can hit enter one more time, and it'll tell us what the minimum or the vertex is. Is everybody able to get this pulled up? Yep. Yeah, so some of these here, it can be a little bit easier to just do it by hand than it is to try to work this out on the calculator. So we went second, calculate. Minimum. So left bound, we need to be the left, okay. And right bound, we need to be to the right of it. Yep. Now the numbers might be a little bit different, but really the X value of this vertex is 2, because some of you might have gotten 1.99999 repeated out or 2.00001. Either way, the X value of the vertex is 2, and the Y value is -3. Guys, let's focus in here. Now, the minimum value, whenever we talk about the minimum value for a function, we're talking about the smallest or biggest Y value. So for this here, it would be -3. Whenever we talk about the minimum value will always be the Y value of the vertex. Now, we could have really just gone on and used the -b over 2a and plugged that in and found it, and it would have been a little bit faster. But then once we found that, we plug it back in to actually get the minimum value. Yes. So let's go back over here. So we said that the minimum value for this here is going to be -3, because this is coming from the vertex value of 2, -3. Now, what would the domain of this function be? We're going to draw that a little better. Well, what is that symbol for? All real numbers. Because again, when we looked at it earlier today, again, both of these functions, the domain is going to be all real numbers. The only time that we really will have restrictions on the domain is if we're talking about rational functions or radical functions, if the variable is in the bottom of the fraction or in a square root or an even root. Now the range is going to be talking about y is, well, at -3, that was the lowest or biggest point. It is the minimum, so it is the lowest point it can be, yes? And we would have all the y values that are going to be what? Greater than or equal to it. So we have y is greater than or equal to -3, and that would be the range. Any questions on any of this here so far before we talk about increasing and decreasing? Okay. I'm going to pull the graph back up here. To -3. So this is the point 2, -3. Now, when we talk about increasing and decreasing, we're trying to look at the graph and see what it's doing. Now, we always refer to increasing and decreasing as along the x-axis, and we start from the left and go towards the right. Now, for us here, the graph starts picking up at about right here. And what is it doing as I go from left to right? It's decreasing. It's going down, yes? Until we hit what? 2 on the x-axis. Even though it's going below and above, that's fine. But as I approach on the x-axis, it continues to decrease until we hit 2. Because as soon as I get a little bit greater than 2, what happens? It starts going back up, yes? So really this function, as I come in from -infinity to 2, it is doing what? It is decreasing. And 2 from 2 to infinity, it is increasing. So it's decreasing from -infinity to 2, and it's increasing from 2 to infinity. Now, according to the book, they're just going to say that to the left of 2, it is decreasing. To the right of 2, it's increasing from that point, the x value, which would work for this here. However, we're not going to always have functions that from the vertex, it'll increase one way and it'll decrease the other, or vice versa. It's not going to be just one or the other in which direction we go. Because we can actually have functions that will increase for a certain amount of time, then decrease, then increase, then decrease. So we can have constant intervals. So if you end up taking this or taking higher levels, especially college algebra, and they ask about where is it increasing and decreasing, they're not going to accept, oh, from the left of this point and to the right of this value. No, they want the actual interval. So when we talk about increasing and decreasing, we're talking about on the interval of the x-axis. Where is that happening? And this is it. That's all we're going to do for this here. Questions on this here? All right. We're going to look at one more. Let's look at B, problem B. Our negative x squared plus 5x plus 9. So let's just go on and graph it. Because if we graph it, we'll be able to see how this function looks and works. So if I'm graphing it, the first thing we'll do is just hit y equals. Well, do we need that previous function in there? No. So we can just clear it out and say negative x squared plus 5x plus 9. Negative x squared plus 5x plus 9. And once we get that typed in, you can go on and hit graph. So is this opening up or down? Down, yes? Because we have the two ends extending down. So will we have a maximum or a minimum value? Maximum value. So we'll have a maximum value. Now, I'll show you this again using the graphing calculator. We can go second trace, and this time we wouldn't go for minimum, we're going for maximum. So we can hit the number 4. So it's wanting left and right bound. Is our little marker already to the left of it? Yeah, so we can go on and just hit enter. Now we want the right bound, the right of it, yes? So there's two ways we can do it. One, we can just keep hitting right till we see that cursor pop back up, or we can track the values. Because if I look at this here, y is 9 right now, 10, 11, 12, 13, 14, 15. Wait a minute. Did we just go back down? So, okay, so we're to the right of the maximum value because we noticed that the y values did increase for a while and now they're coming back down. Now, if I wanted to, I could keep going to the right until it shows back up. But I don't need to. We could have just hit enter a while ago and then hit enter one more time. And it would give us our answer. So this here is telling us that the vertex for this here is the point. So what would the x value be? 2.5, comma, 15.25. That weird decimal, the 0.99 or 0.0999986 is really just the pixel on the screen. It's pixel amount that it's approximating, but it is 2.5 and 15.25. So I'll pull this other screen back up. It means that the maximum value is 15.25. The domain. What's the domain for this function? Well, again, it's going to be all real numbers. The range. Well, since we have a maximum value, we're going to have y is, bless you, less than or equal to 15.25. So we will have increasing and decreasing, and it's really going to be focused on the x value of 2.5, because that's where the vertex is at. That's where it's located at. So if we pull up the graphing calculator, well, coming from the left-hand side, is the graph increasing or decreasing? It's increasing, so it's going to be increasing from negative infinity to 2.5. The value of the vertex. And then it's going to change to decreasing from 2.5 comma infinity. And that's it. That's all we have to do for this here. So it's increasing from negative infinity to 2.5, and it's decreasing from 2.5 to infinity. Any questions on this here? We good with this here? Increasing, decreasing? Okay. Now this here is the last type of setup for the quadratics we're going to look at. So f of x equals a parentheses x minus p times x minus q. And this here is really the intercept equation. Now, the x-intercepts for this here is really whatever value of x is going to make the function equal 0. Well, for here, the values of p and q will make the function equal 0. We'll make the whole thing equal 0. So, the x-intercepts are going to be the values of p comma 0 and q comma 0. Those will be our x-intercepts. Now, it also works out that these intercepts are the exact distance apart from the axis of symmetry. The distance from the axis of symmetry to each one of these intercepts will be the exact same. So if I want to know what the axis of symmetry is, the x value, I can add p and q together and divide by 2 to get the axis of symmetry, or the x value of the vertex. So for this here, we can actually take p plus q and divide by 2 to get the x value of the vertex. And the y value is going to be f of p plus q divided by 2. Let's go on and look at our first example, and this will make a little more sense. Now the x-intercepts, we'll find them first, is going to be p comma 0 and q comma 0. Now what are our values of p and q? 3 and 1, because those are the numbers that are in the places of p and q, yes? Well, now we need to figure out the signs for p and q. Well, in the formula, we have what? X minus p and x minus q, yes? So that means if I have an x plus 3, the sign with 3 should be what? Negative. And since I have an x minus 1, the sign in front of 1 should be positive. Because really what we're saying here is x minus negative 3. Again, it's the opposite sign. Inside these parentheses, we will have the opposite sign. So our actual value of p and q is negative 3 and 1. Questions on this here? So that gives us the x-intercepts. Try that again. Vertex. Well, our vertex is going to be p plus q divided by 2, comma, f of p plus q divided by 2. Well, we can find the p plus q divided by 2 first. Well, what is p in plus q? Well, that would be, it would just be negative 3 plus 1 divided by 2, because we're adding those two values together and dividing by 2. Well, negative 3 plus 1 is? And negative 2 divided by 2 is? Negative 1. Any questions on how we found p plus q divided by 2? Well, the axis of symmetry is x is equal to p plus q divided by 2, so the axis of symmetry is x is equal to what? Negative 1. What's the only thing we have left? It'd be the y value of the vertex, and to find it we just have to plug it back in. So we just need to plug negative 1 back in to the original function. So we'd have negative 2 parentheses. Negative 1 plus 3 times negative 1 minus 1. Well, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. And negative 2 times 2 is negative 4. And negative 4 times negative 2 is positive 8. And that's it. That's all we have to do for this here. Any questions on this here? Any questions on anything we've done thus far? We'll look at one more, because I think at least one more would be good. Do you all have a preference on which one out of the next three we want to look at? This one here? All right, let's look at this one here. So this one is the last one that we do have. So, unlock. Go on. Okay. It's just the same problem. Now the x-intercepts are going to be p comma 0 and q comma 0. So we need to find the values of p and q. Well, what are they going to be? 6 and 2. Now, since both of them is 6, or x minus 6 and x minus 2, they will both be positive or negative? Positive, because since the minus is already on the inside, they stay positive. Now the next thing we need to find is our p plus q divided by 2. So we'll have 6 plus 2 divided by 2 because we're just plugging in p and q. Well, 6 plus 2 is 8. And 8 divided by 2 is? So the x value of the vertex is 4. X equals 4 is the axis of symmetry. And the last thing we need to do is plug it back into the function. Any questions on this here before we plug it back in? Okay, so we'll have 1/4 of 4 minus 6 times 4 minus 2. Well, 4 minus 6 will be negative 2. 4 minus 2 is 2. Let's save the fraction till the end. Negative 2 times 2 is negative 4. What is 1/4 of negative 4? Negative 1. So the vertex is the point 4, negative 1. The axis of symmetry is x is equal to 4. And our two x-intercepts are the point 6, 0 and 2, 0. Questions on this here? Any questions over anything we've covered? All right. And that is it.